So today we're going to be looking at substitution practice. I'm going to teach you a cool little hint, especially if you're dealing with fractions, for the slope and the y-intercept. So, when we're substituting equations into each other, you can have one number in the slope-intercept form, which is y equals mx plus b, and plug it into the second equation for y. So, this says y equals mx plus b, right? So since this is set to y equals, and remember y is just a placeholder, what I can do is take this 5x plus 12, plug it into my y, and make sure you use parentheses, just like here. Thus, I'm going to have the equation 2, parentheses, where my y would be, since I know what y is, which is 5x plus 12, end parentheses, equals 15x plus 16. Now this is a lot easier, especially when you're dealing with fractions. So like if I was going to put both of them into y equals mx plus b form, look at this. I'm going to have an ugly fraction here of 15 over 2. It's a lot easier to have one of the equations in y equals mx plus b form, plug it into the other y, and then solve. So if you have them both in y equals mx plus b form, then just set them equal to each other. But sometimes this comes in handy, especially for fractions, and nobody likes fractions. So I'm going to show you some practice problems to show you, hey, you can use this as another strategy. So I'll show you the original way that we learned it yesterday and why this way might be a little bit easier for you. So I'm just going to quickly do this, so don't write anything down yet. I'm going to do it really quick and show you what's happening. So if I wanted to put the second equation into y equals mx plus b form, I'd add 2x to both sides, and what would happen is I get 3y equals 2x minus 7, right? And then we always divide by whatever's attached to y. Now look at this answer right here. I'm going to write it in black. Y equals negative 2/3 x plus a 7 over 3. Who the heck would like to deal with fractions during all of this? Nobody. Especially setting them equal to each other. Just a little bit more of steps. So I'll show you why this method works, especially if you have problems where you're going to have fractions for your slope and y-intercept. So we have y equals 6x minus 11. What I'm going to do is take this 6x minus 11, plug it into where y is for the second equation, because this is what y equals. Now I know what y equals, right? So I have negative 2x minus 3, parentheses, 6x minus 11, end parentheses, equals negative 7. So you'll see in a second how much easier this is. So just like any other equation that we've been dealing with, make sure you distribute. So negative 3 times the 6 is going to give me a negative 18x. And the negative 3 has to go to the negative 11. They're both negatives, so it's going to equal positive. And I didn't do anything to this negative 7 or this negative 2x. So bring them straight down so everything is in line. So now I can combine like terms. I can combine this negative 2x and this minus 18x. And if you remember, keep change. I'm essentially adding a negative 2x and a negative 18x together to give me negative 20x. Did I do anything to this 33? Nope. So just bring it straight down. Same thing with this negative 7. So, again, solving for x, is x by itself? Nope. So we're going to kick the 33 out and move it to the other side. Positive 33 minus the 33 is going to cancel. On the left side, I'm going to be left with negative 20x equals a negative 7, and a negative 33 is going to be more negative, so I'm going to get negative 40. And last step, like always, is x by itself. Nope, so all I need to do is whatever's attached to x, I need to divide by both sides. Now remember, carry your negative with it. A lot of you guys keep forgetting to carry the negative with it. So a negative divided by negative is a positive. 40 divided by 20 is 2. So this is a one solution problem for systems. Let's try the next one. So in this case, we have to put one of them, or both of them we can, into y equals mx plus b form. For this problem, I'm going to put them both into y equals mx plus b form because I can notice that all of these are 2's, so it's going to be kind of easy. So in order to get this by itself, I'd have to subtract the x, so I'd get negative y equals, here, let me move over here. I'd get negative y equals a negative x minus 2. And remember, there's an invisible negative 1 here. Well, the 1 is invisible, but the negative's not. So you have to divide everything by negative 1. So my equation would be y equals x plus 2 for the first one. Okay? Then I need to get y by itself for the second one. So I'm going to do the opposite of negative 2x and add 2x to both sides. So I bring down the 2y equals 2x plus 2. And y is not by itself, so I'm going to divide everything attached to y divided by everything, because it's a 2. 2 divided by 2 is 1, so x, and 2 divided by 2 is 1, so there's my second equation. Now I can set them equal to each other. So what you're going to do is take this x plus 1, plug it into y here. So you have x plus 1 equals x plus 2. Now I can combine my x's to one side because we always want to see all the x's on one side and all the constants on the variable, or the constants on the other side. So I'm going to actually subtract this orange x from both sides. 1x minus 1x is 0. And I'm left with 1 equals, on the other side the x's cancel, and I'm left with 2. Oh no, can 1 equal 2? Absolutely not. So I'm going to put a slash through the equal sign and say no solution. Okay, so sometimes, like the one we just did, we had fractions for our slope and y-intercept. So in this case, we didn't. So all we did was use the substitution method of putting them both into y equals mx plus b form and subtracting them or equaling them to each other. So for this one, I have y equals negative 3x plus 5 and 21 plus 3y equals 15. I want you to choose whichever method you think you want to try. You can do both and see if you get the same answer. What I'm going to do is I'm going to take, since I already know what y is for one of them, I'm going to take whatever that y equals and plug it into this y. Now at this point, I want you to pause the video. I want you to try which way you would like to try. Would you like to put them both into y equals mx plus b form, or plug this y in? Now that you've done pausing it, you're going to, so let's solve it out. So I have 21x plus 3 parentheses 3y, I'm sorry, not 3y, negative 3x plus 5 equals my 15. So I'm going to distribute what's a negative times a positive, so I have negative 9x. And a positive times a positive is a positive, so 5 times 3 is 15. And since I didn't do anything to the 21x and the 15, I'm just going to bring them straight down. So now combine your x's together. 21 minus 9 is what? It's going to be 12. So I have 12x plus 15 equals 15. Okay, get x by itself by subtracting 15 to both sides. Oh no, look, I got a 0, which is okay. Is x by itself? Nope. I gotta divide 12 by both sides, regardless if it's a 0 on that side. Because x is gonna equal what? 0. Anything divided by 0 is gonna be 0. So this is actually one solution. X can only equal 0 for this solution. Alright, so I'm going to try it the other way. I'm going to get these both in the y equals mx plus b form. So I'm going to subtract 2x first. So I have y equals negative 2x plus 6 for my bottom equation. And for my top one, I'm going to get rid of my x by adding it to both sides. Remember, x and negative 12 can't be combined because 12 does not have a x. So I have negative 2y equals 4x minus 12. The last step to do is to divide by negative 2 to everything. So these negative 2's will cancel. I'll be left with y equals, what's a negative divided by a positive? A negative. 4 divided by 2 is 2 with the x. And the negative divided by a negative is a positive. 12 divided by 2 is 6. Now I can set them equal to each other. So I'm going to take my equation, y equals negative 2x plus 6, and plug it in right here for the other equation's y. So now I have negative 2x plus 6 equals, which I'm right here, negative 2x plus 6. They're the same equation. Can you notice, remember when we talked about the different types of solutions when both of the equations are the same on either side? What does that mean? It means it's going to be infinitely many solutions. Woohoo! That means that x can be any number and it'll still equal each other. So now that we practiced a few problems and you are starting to feel a little bit more comfortable, and if not, it's totally fine. Look back through this video or other videos that I have on your digital notebook. And what you're going to do now is go into your summit and complete checkpoint 3. Those 4 problems are similar. You can do it either way. You can have one equal to y and plug it into the other equation y, or you can solve it out like we did for this last one and have them both be in y equals mx plus b form. It is completely up to you. I mean, try both ways. Try on 1 and 2, plugging in one equation into the other for the y's. And then for the other 2, put them both into y equals mx plus b form, because sometimes you don't know. But give it a try, and let's go.